Good evening, Mr. Gubino here. We're going to do the circuits training for review of tables in calculus. So you have this to download if you would like to follow along with it. I'm going to do a couple problems. I'm not going to do the whole thing, but I will post the answers so that you can check your work. I'm going to tackle the harder ones a little bit, but try and get into the ones that are ones that you've seen before and maybe not fully seen. Okay, so we're going to start with number one, which is this first one. So we're going to, if you notice, they have a table of values, x values, f, f prime, g, g prime, h, and h prime. So what we're going to do is we're going to work this problem, find the answer, and then find what we have. Notice this is number 8. This is the 8th one you're going to do. So the 7th one is going to have that answer of 4 pi. So I zoom that in. They want to know what k prime of 2 is, and k of x is f of x plus g of x, and because it's addition, we can just take the derivative. So k prime of x is equal to f prime of x plus g of x. This is always good to show your work whenever you are asked to do this. Even on the test, this will be a good skill to show because it is showing the calculus and seeing if you know the calculus from what they're giving you. So they want to know k prime of 2. So anytime that I see an x, I am going to replace it with a 2. So k prime of 2 is f prime of 2. So there's 2. F prime is pi. And g prime of 2 is 7. So k prime of 2 is pi plus 7. So that will lead you to number 2, and number 2 is over here with this one. We'll do this one again. Alright, so j of x is 3 times g of x minus 2 f of x. They want to know j prime of 1. So we're going to find j prime of x before we do anything. So this is a constant times that, and we're subtracting. So it's a constant times a function minus a constant times another function. We can just do the power rule for this. So this would be 3g prime of x minus 2 f prime of x. Because if we think about it, that 2 is going to be distributed to everything. It's going to come out of everything out anyways. So we're just going to leave it out of there. So j prime of 1. And once again, you want to show kind of every step. You should be sort of getting used to writing every step down. So we're going to do this 3 times g prime of 1. G prime of 1 is 4. 2 times f prime of 1 is negative 3. So we have 12 minus 2 times negative 3 is plus 6, which is 18. So we're going to go with 18, and that goes back onto the first page. I want to skip down here, down to the bottom right. This is the 12th problem that you are going to do. So this is the last problem, which is going to take you over to the first problem once we get that done. So this is the integration. So it's a definite integral from 5 to 3. So whatever we get, we're going to go from 5 to 3. Well, we have to recognize what that is. So if we have a function times the derivative of a second function plus the second function times the derivative of the first, that looks like the product rule. So if we're looking at the product rule would be the two functions, f of x and g of x. And we're going to multiply those two together. So when we multiply those two together, and we're using the definite integral, we're going to do f of 5 times g of 5, and then we're going to subtract f of 3 times g of 3. Okay, so you're going to find what f of 5, g of 5, f of 3, and g of 3, and then that should come out to be, I think, the 18 minus 5e is what I got. So we're going to go to another one here in just a second. Okay, we're going to look at this one, the 10th one that we're going to do, but again, it's kind of a this fundamental theorem of calculus situation here. It says let w be the function given by w of x is the integral from 1 to h of x of f of t dt. Find the value of w prime of 3. All right, so what we need is the derivative. Well, if we take the derivative of each side and we take it in terms of x, basically what happens if we take the derivative of an integral, we're just going to have what this function is. So this is going to give us w prime of x. Great. This is the fundamental theorem of calculus. This is that dummy variable. It's a constant to a function. And in this case, it's h of x. Anytime that you see a function in there, I'm going to zoom in just a little bit. Anytime that you see a function in there, this is going to be f of, and this t is going to be this value up there. So if you notice, it's going to be a composition. But when I put it into a composition like this, what I have to do is, because I'm using that, I have to consider the chain rule and how to get that. So what I have to do is multiply by the derivative of this function, or of this function. So I think you saw it on a couple videos before, where we had the integral from 1 to x cubed, and we had to do the derivative of x cubed to get that value. So when you're doing these and you're plugging in a value, for example, if I had something like this of, let's say it was 1 to x squared of f of t dt, and this would be f of x squared, whatever x squared is put into that, but then I would need to multiply it by the derivative. Okay, so when I multiply it by the derivative, it's going to give me that integrand. All right, so in this case, if we're looking at w prime of 3, we need f of h of 3 first. We need h of 3 first, and then we need to find it with f, and then the slope at 3 of h. Okay, so I think we have, this becomes 1, because if we use h of 3 is 1, and then we got to find f of 1, which is 4. So this value becomes f of 1, which is 4, and then times h prime of 3. H prime of 3 is negative 3/4, which cancels out the 4's and gives you a value of negative 3. All right, so if I move it up, you can actually see what I just said. So h of 3 is 1, therefore f of 1 is 4, and f of 4 times h prime of 3, which is the slope at 3 of h, we get a value of negative 3. Which leads us over to this one with the inverse. So the inverse functions, I'm going to kind of go over a little bit with inverse functions one more time. All right, so g to the negative 1, it's not to the negative 1 power, is the inverse function of g, which means that g of g inverse of x is going to be x. If they're inverses of each other, they're going to have a value of x. Now you can go through this, you can find the derivative of each side, and ultimately what's going to happen is you're going to get 1 over g prime of g inverse of x. I'm going to do it a little bit differently. So if the inverse of g has an x, if g has an x value of, g inverse has an x value of 2, which means that g has a y value of 2. And if I look at g and the y value of 2 means that the x value for g is at 1, which means that the y value here is 1. Because they are inverses, they're just going to flip sides. So if I know what the slope is at 1 of g, which is 4, then I'm going to know what the inverse slope is. And in this case, I want to know the slope inverse at 2, because I want to know what it is at 2. I'm going to flip this. So this is going to be 1/4. Okay, so there's your answer for 1/4. I think that takes you to the second page to that number 12 with the product rule. If there are any questions on this, please feel free to contact me. I am going to post this video with the answers, and we'll talk to you soon. All right, so make sure you're checking your emails, make sure you're doing this stuff to keep yourself up to date on the calculus for the AP test online. Okay, we'll talk to you soon.